Let's go to page 483. This is lesson 10-7. The objective of this lesson is to use exponential and logarithmic functions to solve growth and decay problems. So the first type of problem that you come across is the compound interest problem. So on page 43, the compound interest formula is A equal to P times 1 plus R over N times NT. So A is amount of money. Okay, so this is the amount after time, after a certain time. Okay, the P is a principal. So this is the initial amount. Okay, and R is the interest rate. Okay, so that's R. And N, so T is time. And N is number of times that compounded per year. So number compounded per year. Okay? Okay, so the way this works is, let's go over example 1. Okay, so example 1, so write down everything as you read. It says how long, that means T is looking for time, right? How long will it take investment? So the investment at your starting amount, so P equal to 1,000. Okay, so again, so investment of 1,000 to triple. Okay, so that means amount at the end, it triples to be $3,000. Okay, if it's invested at annual rate, so R equal to 12%, so you have to convert into decimal, so equal to 0.12. Okay, and compounded quarterly. Quarterly, that means N equal to 4, because if it compounded quarterly, that means it's compounded 4 times per year. So the N equal to 4, because it compounded 4 times per year. Okay, so you just substitute everything in here. So you're going to get 3,000 equal to 1,000 times 1 plus 0.12 over 4 to the 4 times T. And that's what you're looking for. Okay, to solve this, first let's get rid of the number in front. So divide by 1,000 on both sides. So that this we cancel. You have to get rid of the number. So you're going to get 3 equal to, now you have to simplify this part over here, so this would be 1.03, right? 0.12 divided by 4 is 0.03 plus 1 will give you 1.03 to the 4t. Okay, so now your equation is simplified a little bit. And after that, to solve this, when a variable is in the exponent, you have to take the log on both sides. So take log on both sides. Okay, then after that you can apply the third law to bring this down to the front. Okay. Now to solve for t, you have to divide by 4, divide by log of 1.03. So divide by 4, so this will cancel out. Divide by log of 1.03, divide by log of 1.03. So you don't need parentheses anymore. Okay. So you got t equal to log 3 over 4 log of 1.03. Okay? So now you have to use calculator to work it out. So you're going to 3 log. You have to divide by 4. Then you have to divide everything on the bottom. You have to divide. So divide by 1.03 log. And you push equal. So you're going to get t equal to 9.29 years. Okay. Now you cannot leave it as as the decimal like this because it compounded quarterly. So you have to run it up to the nearest quarter. Okay, so nearest quarter would be 9 1/4, right? Because this is closer to 0.25. Okay, so it's either 9 1/4 or 9 1/2. So this is closer to this than this, right? Because this is 9.25 and this is 9.5, right? So this is closer to this. So you have to run it off to the quarter because this is compounded quarterly, okay? And so that would be the answer. Okay, let's go to the next one. On page 484, here is a double time growth formula. So you got n equal to n0 times 2 to the t over d. So this is the number at time t, so number at time t. Okay, so this is number at a certain time. The n0 means at time 0, so this is a starting number, starting amount. Or the population or whatever, right? So again, 2 because it doubles every whatever, okay? Now this is the time, okay? And this is the time it takes to double. Time it takes to double. Okay. So let's go over example 2. Okay, it says a certain bacterial population double in size every 12 hours. Okay, that means D equal to 12 hours. Okay, that's the time it takes to double, so 12 hours. By how much? Okay, so by how much? So you're looking for n. By how much will grow in 2 days? So T equal to 2 days. Now, because this is hours, so you have to convert this into 48 hours. Okay? Okay. So let's go and put everything in the formula. So n equal to n0 times 2 to the t is 48 over d is 12. So n equal to n0 times 2 to the 4. So n equal to 16n0. Okay? So at the end equal to 16 times the beginning. Okay? So it will grow by a factor of 16 in 2 days. So it will become 16 times as much. Okay? So answer would be factor of 16. Okay, so again, it will grow 16 times as many in 48 hours. Okay. Now the next one is kind of the opposite. The next one is very similar to this. So on page 485, you have the half-life decay formula. So you got n equal to n0 times 1/2 to the t over h. So instead of doubling, instead of making instead of growth double, you're going to make a half. So again, it's the same thing. Okay. So this is amount at time t, and this is the initial amount. Or the starting amount. And half is how long it takes, it become half. Okay, and this is a half-life. So this is from your chemistry. Okay, so half-life, because what happens in chemistry, there are certain substances that is radioactive. And so after a certain amount of time, it will decay half of them. Okay, and so this is the time. Okay, so the half-life is how long it take for a sample to decay into half amount. Okay, so again, this is from your chemistry. So instead of doubling, you make a half. So everything else is the same. Okay, so let's go over example. So example 3, it says a half-life of a carbon-14, so that's H. The half-life of a carbon-14 is 5,730 years. Okay? How much, so you're looking for N, how much of a 10 milligram, so N0 equal to 10.0 milligram. So that's your original amount. So, and then after, so T equal to 4,500 years. Okay, so you start with 10 milligram, and after 4,500 years, how much of that sample will be left? Okay, and the half-life is this. So you can get your formula. So you got N equal to N0 is 10.0 times 1/2 to the T is 4,500 over half-life, so 5,730. Okay, so get your calculator. So on this one, make sure that you know how to use your calculator. Okay, so I'm going to just do it by 2 steps. So I'm going to figure out this part first. Okay, so it'll be 1/2, and it's going to be 2. And the fraction normally will only allow you to enter 3 digits. So I'm going to cancel this 0, so I can enter 450 over 573 equal. Okay, so this will give me 0.5802. Okay, and again, just don't erase since I already have this on here already. So don't erase. Just use this times by 10 equal. Okay, so N will equal to, and normally you run out to 3 digits, so it would be 5.80 milligrams. Okay, and the reason I use 3 digits because there are 3 digits. Okay. And so only 5.80 milligram will remain after 4,500 years. Okay.